problem, we will be drawing the ion of NO3 -1. The first thing to do for Lewis dot structures is to find the valence electron. So you find N. N has 5 valence electrons, and there's only one N in the compound. Oxygen has 6 valence electrons, and there are 3 oxygens in the compound. So you add those up together, and you get a total of 23. Now if you look, there's a -1 charge on NO3, which means we have to add one more valence electron, because the compound needs to have a -1 overall charge. So this allows us to use 24 electrons. So we're going to draw the skeletal structure with N in the middle and the 3 oxygens surrounding it. We have now used a total of 6 electrons drawing the skeletal structure, leaving us with 18. So we will begin with 1 oxygen and satisfy the octet rule for that oxygen. Subtract the 6, that leaves us with 12. Go to the next oxygen, do the same thing. This leaves us with 6, and the last oxygen, we also need to add 6 more, leaving us with a total of 0 electrons. Now if you look at nitrogen, nitrogen currently only has 6 electrons, 2 from each of the bonded pair. However, it needs 8. So what we're going to do is we are going to create a double bond. You're going to take 2 electrons from the oxygen and create a shared pair. The new Lewis dot structure now will be the same thing, except for the bottom oxygen is going to share 2 electrons, creating the double bond. We now need to represent the -1 charge, so we're going to use brackets, -1. You can also write the resonance structure. Resonance just means the double bond or triple bond is in a new spot. So we can use the upper left-hand oxygen and put the double bond there. Or you could even do it on the upper right-hand oxygen. So now if you look, all of our elements have a total of 8 valence electrons, each of the oxygens and the nitrogen. So I want you to try to draw the Lewis dot structure of CO3 -2. Don't forget to make sure all elements have 8 valence electrons.